Hello, welcome everyone. Today what we're going to discuss is sine diagrams. So, by the end of today's lesson, you're going to be able to do a couple things. You're going to be able to draw a sine diagram from a graph. You're going to be able to draw a sine diagram from an equation and also a rational equation. Right? Rational equation, same technical thing. One's almost like a polynomial type, the other is a fraction. So, what do you need to know to do this? What all this stuff means. So first off, what exactly is a sine diagram? Now a sine diagram, okay, sometimes we don't wish to draw the time-consuming graph of a function. We only want to know when the function is a couple things. Okay, there's four things we want to know. What do you think those four things are? Okay, they are when a function is positive, when a function is negative, when a function is undefined, or when a function equals 0. Those are like the main portions of a function. Everything else between, you can pretty much connect the dots. All right, so for the function f of x, the sine diagram consists of the following four things. Okay, every sine diagram has the same parts. Not all of these are in there, but these are the only parts you would see in a sine diagram. The first one is a horizontal line. So what exactly is a horizontal line? It represents the x-axis. Horizontal lines are like this, right? And they have little arrows on each end, meaning they go on for infinity. So when you draw a sine diagram, you're just drawing the x-axis. So it's like a one-dimensional diagram. All right? Got it so far? Next one. Positive. So the positive portion is where the graph is above the x-axis. So if you have a sine diagram, and I'll draw a little one right here, you would first start by drawing your horizontal axis. Now every sine diagram has that axis. Now, positive is where the graph is above. So say you have a graph right here. I'm going to give you a quick rundown. All right, and your graph looks something like, I don't know, that. Okay, wherever this graph is above the x-axis, right? So from here to here, and then from here all the way to here, your sine graph would have little positive symbols above it in those sections. Negative, wherever the graph is below the x-axis, okay? So for instance, it's below right here, and it's below right here. So you would have negative pieces right here. That's where it's below, okay? So this sine diagram is a bunch of plus signs and minus signs that tells you where your graph is above and below the actual x-axis, okay? Now, you have something called zeros. Zeros are where the x-intercepts of the graph y equals f of x. So, where this graph intercepts the x-axis, these points right here, where the graph goes from being above the point to below the point, okay, or where it just touches the x-axis, right, the intercepts, those are called your zeros, all right? Now, they are also the roots of the equation f of x equals 0. So when you intercept the graph, you can either go through the x-axis, or you can just like touch it and bounce back up. So you'd still be positive, positive, or negative, negative, but you are still intercepting the graph. And it's also the values of x where the graph is undefined, okay? That's the last piece. So you have a 0 where the graph is undefined as well. So where the graph equals 0 or where it's undefined. All right? Pretty simple stuff to do. All right, so what we're going to do here is we're going to consider the functions below. We have three of them. Y equals x plus 2 times x minus 1, negative 2 times x minus 1 squared, and 4 over x. So three different types of equations. So these are the graphs of these equations, and they are representing three different types of sine diagrams we would use. So the first thing you do is you always want to find out where your zeros are, where this intersects the x-axis. So right here at negative 2 and at 1 is where it intercepts. So then you would write those numbers down on your sine diagram. So far we have a horizontal line, which you always start with, and then we write the y-intercepts on that graph. The second step is to put a plus where the graph is positive, or above the line. So right here, notice this graph is above the line, right? So you'll put a positive, because this section right here is 0.1, 1, 2, 3, 4, all these values right here are above the x-axis. Now, between negative 2 and 1, these values right here, they are all what? they are all below the x-axis. So that's where you would write a minus. Okay? And then you finally got this last piece right here, and this arrow just means it goes on to infinity. And what are these? These pieces are all above. So you got above, below, above. So what would we put here? You would put a plus. And that's what a sine diagram is, this thing down here. Plus, minus, plus. And that's it. Very simple concept. Ready? Y equals -2, x minus 1 squared. So, notice this one does not go through the graph, but it does touch it. So just because it touches it, it still is a x-intercept. It still intercepts the x-axis. So that still is one of our points on the graph. So you would still have to represent it with whatever number this is, which is 1. Now, what are these points right here? Are they above the graph or below the graph? Well, let's look. Here's the x-axis. You have to go down to get there. So they are minuses because they are below the x-axis. Okay, so now we go here, from here to infinity. Oh, look at this. These are also all below the graph. So it's not necessarily plus, minus, or minus, plus, minus, plus. You can have minus next to minuses and pluses next to pluses. Right? Next problem. Y equals 4 over x. Now this one here is a rational number. And what we're going to do here is, what do you notice is different than this one? There is no x and y intercepts. But what is there? Right there. At y, or x equals 0 is a asymptote. So you have an asymptote. Asymptotes are where your graph is undefined. That is a 0, your asymptote. So you put 0 there. So from negative infinity to here, this whole portion of the graph is all below, right? Everything here is below the x-axis. And everything after the asymptote is all what? Above it, so that's a positive. And that's all you have to do. That is the entire graphing a graphical sine lesson. All right? And by sine, it's not sine cosine. It's like S-I-G-N, the sign, like plus or minus sign. Right? So, here is, that was the visual people. Here is the people that are better with the verbal. Okay? So, same equations we just used. They correspond to the same problem. So the first one says, a sign change occurs about the 0 of the function for a linear factor such as single linear factors such as x plus 2 and x minus 1. The graph, what the x-axis? It cuts the x-axis, okay? By cutting it means it goes through. Right? So if the sign change occurs about the 0 for a singular linear factors, it cuts it. So that means when a factor has a blank, there is a change of sign about that 0. So when a factor has, jumping ahead, no sign change occurs about the 0 of the function for squared linear factors. So when you square something, what happens is, if the answer is negative, it becomes positive, or if it's positive, it becomes positive. So this, whatever sign is in here, is going to be positive because of the square. If there's a negative in front, it's all going to be a negative, positive number. They're always going to be negative. So if you square something, if you raise something to the 4th power, if you raise something to the 8th power, like an even power, the graph doesn't cut it, but it just touches it. That's when the graph goes up and goes back down. So it just touches it, but it stays in the same quadrant. So you're saying the lower half or the upper half. Now, what are these little guys? Little dashed line known as an asymptote. That indicates that the function is undefined at x equals 0. So these are the 3 times that you will have a 0. Now, when a linear factor, and also when there's an open circle, that's a 0 as well. When a linear factor has a blank, there is a change of sign above the 0 when it has an odd power, okay? Odd power, odd power. When it has a, I jumped ahead, an even power, there is a no sign change. Because as I said before, 2, 4, 6, 8, the even power keeps the sign the same no matter what's inside. All right, not too terrible, right? Good. I'm feeling a lot of energy today, hopefully. Do these problems. All right, so this is example number 7. We'll do this together. Hopefully you're able to do it on your own. If not, I'll help you out. So first step is to find out and do. Where are the zeros? Where does that graph intersect the x-axis? So, I'll give you a hint. It's 3 places. Draw the 3 points, and then just take the straight edge and draw a line straight down. I gave you a packet to use on these to help you out. So, your 3 points are -2, 1, and 4. Transfer them down. -2, 1, and 4. And now you go, okay, in between these pieces of graph, is my graph above it or below it? What do you got? Below. Below means negative. Above. Above means positive. Below. Negative. Above. Positive. Alright, and this is what I mean. This is below. This is below. So they're both negative, right? This is above. This is above. So from here to here is your positive. From here on is your positive. Between these 2 pieces is your negative. And from there on is your negative. Negative, positive, negative, positive. All right? Problem B. Problem B, you have to draw a couple asymptotes. How do you know? Well, look, if this goes on forever, this goes up forever. If they did mix match and cross each other, it wouldn't even be a function. And this says, draw a sine diagram for, I told you, the function. So there's a asymptote at x equals -2, and there's an asymptote at x equals 3. All right, so they should have actually just been shown to you. I don't know why I introduced them like that, but sometimes you have to create them yourself. Those are my 2 zeros. -2. This intersects here at 1/2. On your paper it said 1/2. I should have had that written there for you. All right. So what you're going to do is you're going to say where it's increasing, decreasing between that stuff. All right. You got your answer? Positive. Remember, this is what we're dealing with. Above, positive. Below, negative. Above, positive. Below, negative. All right? That's it. Try example number 1. A, B, and C. So you're writing the sine diagram for all 3 of these pieces. Okay. All right, start with that. Intersects the x-axis, not the y. So it only intersects the x-axis right here. So where does it cut this axis? I'll put this on here. That's my new x-axis. What number is that? Intersects at 2. All right. Anything before 2 is negative. Anything after 2 is positive. All right. Intersects twice. -1 and at 3. Negative. Above is positive. After is negative. All right. And you don't have to draw these dashed lines. It just shows you how it works. Intersects twice. All right. 0 and 2. Above is positive. Below is negative. Above is positive. Okay. That's it. All right. Any questions? Any questions? Any questions? DEF. All right. You get as much time as it takes you to walk across the board. That's the y-axis. That one doesn't matter. Right here does though. So it intersects the x-axis at 1. That's your 0. Everything before is positive, and everything in after is also positive. All right. Same thing here. It intersects at -2. That's when my graph is 0. That's what a 0 means. So this value at -2 is 0. Negative, negative. So there's no positive values in the graph of E. 3. 1, 2, 3. The three graphs are at -2, 0, and 2, all 0. So this is above, so it's positive, below, so it's negative, above, so it's positive, below, so it's negative. All right. Next set of problems. GHIN. That's it. Ready? No 0 here, but there is an asymptote at 0. This is an undefined piece. Everything to the left is negative. Everything to the right is positive. All right? -1 and 2. Not at 0. That crosses the y-axis. That's allowed. All positives. Watch this. All positives. And then negative. So plus, plus, minus. So sometimes you have them attached. Same, same, different. Or different, different, same. Or different, same, different. Any combination is possible. Well, look at this one. Looks like an M for McDonald's, right? I'm getting a little hungry. All right. You have 3 at -3, 0, and 4. Below is negative. Above is positive. Above again is positive. And then below is negative. Okay. That's it. JKL. Between 1 and 2. Now, at x equals 1, you have an asymptote, so that's undefined, and at 2, it crosses the axis. So let's look. From -infinity to 1, this whole graph is above the line, so that's a plus. From 1 to 2, it's all under, so that's a minus. I had to squeeze a little minus in there. And then above this, all to infinity, is a positive. Plus, minus, plus. This one right here, use your asymptotes. You have -1 and 2. And then you also intersect the x-axis at 0. It's like a tongue twister. Below is negative, above is positive, below is negative, and above is positive. Don't worry, it gets tougher. -2, 2, and 0. You're dealing your x value, not your y value. Oh, wait. Got you. -2, 2, -1 and 1. It's where it crosses this axis. 0 is not 1. Did you fall for it? Did I really mess up, or did I try to trick you? You're never going to know, are you? All right. Anyway. Before you get to -2, it's under, so that's a minus. Between these two, so between that and this, it's above. Between my green and this one red, if I extend it up, it's above, so that's a plus. Between these two reds, it's under. Between this red and this green, it's over, that's a plus. And then after this green, it's under, so that's a minus. Minus, plus, minus, plus, minus. All right? All right. Seem pretty good? Awesome. Oh no. Can we just stick with these? Aren't these easy? No, we can't. I wish we could, but unfortunately we can't. So we're going to go to example 8. We're going to draw a sine diagram now, and now we're going to draw them for functions. Okay, so we're going to start with simple functions, and then just getting more increasingly difficult. Like I said before, we do the little ladder approach. Start at the bottom of the ladder and move up, move up, move up, and make it a little bit difficult. Throw things on as we get towards the top of the ladder. X plus 3. X minus 1. So, when you solve for a diagram, you want to know where the zeros are, right? So when f of x equals 0, how do you figure that out? How can we do this? You just set x equal to 0. That's all you do. So you set x equal to 0. So you solve for x, making it 0. All right, so now how can we do this? Well, each one of these pieces, if this is 0 times this is equal 0, 0 times this equals 0. So we take every part of the equation that's being multiplied, and we set it equal to 0. So we just say, okay, x plus 3, x minus 1 equals 0. All right, that's all you do. You set the equation equal to 0. Now, what do we do next? You remember how to do these? You do, okay, x plus 3 equals 0, and x minus 1 equals 0. You set each one equal to 0, because 0 times x minus 1 is 0, x plus 3 times 0 is also 0. Or to solve this, we're going to subtract a 3 from both sides. All right, if you forgot your algebra, you do minus 3, cancels out, x equals negative 3. Right here, you're going to add 1 to both sides. All right, cancels that 1's out, and you get x equals 1. Very simple algebra. So what do we know about the negative 3 and the 1? They are our zeros. We have zeros at negative 3 and 1. So what I do is you have to go in ascending order. That means lower number to the right, highest, lowest number, then you go number, ascend higher, and then you get the highest number at the right. So we put a negative 3 here and a 1 here. Does it matter where I put the numbers on here? Not really. It doesn't matter how you separate it or how you go about making your numbers, as long as negative 3 is on the left, 1's on the right. So, now what do we do? Now we have to see if this is plus, 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 minus, 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 plus, minus, plus, minus, minus, so on. We don't know how this operates. So how do you think we go about figuring that out? All you're going to do is you are going to take a number before negative 3, less than negative 3, and plug it into the original equation. If the value is negative, all the values lower than negative 3 are negative. If you plug in a number into this equation less than negative 3 and the value is positive, all the numbers less than negative 3 are positive. So I am going to substitute any number. Oh, I'm starting with every number greater than negative 1. Substitute any number greater than negative 1. I picked 2. Why do I pick 2? Because 2 is on this side. So 2, I just said it backwards, represents all the numbers between 1 and infinity. So whatever sign 2 is, every other number will have that sign. So 2 plus 3 times 2 minus 1. 5 times 1 is 5. We don't care about this number. We care about the sign. That is a positive number. So that means all the numbers to the right of 1 are positive. If you don't believe me, pick any number you want that's larger than 1. Let's pick 10. I'll pick one. I'll pick 10. 10. 13 times 9. Oh, yeah. 90, 117. Positive. All right, see that? All right, what do you think you do next? Now you're going to substitute any number between negative 3 and 1. Now what I always like to do is anytime I have a chance to enter 0, 1, I like to do that, or 1, I like to do that, because whatever number you pick between these two is going to represent the sign that all the numbers fall in. So I pick 0. 0 plus 3 is 3. 3 times negative 1 is negative 3. What kind of sign is that? That is a negative sign. So every number between negative 3 and 1 is negative. If you don't believe me, I'll pick negative 1. That should be negative, right? Because between the two. Negative 1 plus 3 is 2. Negative 1 plus negative 1 is negative 2. 2 times negative 2 is negative 4. Negative number. See? And then you're going to pick a number, what do you think? Greater than 1, between negative 3 and 1, and less than negative 3. So any number less than negative 3 is going to represent all these numbers. So I like to pick a number nice and close, negative 4. You can pick negative 10, negative 20. You can't pick 0. The number has to be less than negative 3. All right, so this number right here is a number that was greater than 1. This number was a number that was less than 1 and greater than negative 3. And this number right here is a number that was less than 3. All right, now, the reason you don't pick, what would happen if you picked 1 or negative 3? If you actually picked one of these answers, your answers would be 0 and 0. Okay, those are your zeros. Anyway, negative 4 plus 3 is negative 1 times negative 5 is a positive 5. So all the numbers less than negative 3 are positive. Let's see, let's pick negative 10. Negative 10 times 3 is negative 7. Negative 11. Negative 7 times negative 11 is positive 77. Positive number. All right? try B. Pretty easy. Once you get the hang of this stuff, it's cake. All right. -4, x minus 3 squared. All right. Got it? X minus 3, you divide both sides by -4. Here, to get rid of the -4, because if I do that, this cancels out, becomes a 1. 0 divided by -4 is still 0. Since there's no variable attached, you really can't set it equal to 0. X minus 3 equals 0. Why do I do that? Well, if I square root x minus 3, squared, the square root goes away, square root of 0 is still 0. So whenever x minus 3 equals 0, this whole thing equals 0. All right, so add 3 to both sides. I don't know if I need to write all this stuff down, but I'm just assuming one person may not get it. And you get x equals 3. So what that means is 3 is my only 0. You have a 0 at 3. So everything before 3 is going to be a certain sign. Everything after 3 is going to be a certain sign. Now, do you think those signs are going to be the same or different? Even power. What do you think? It should be the same. But you still have to do all your work to make sure you check. So, what number are you going to pick first? You should pick a number greater than 3. What number do you think is close to 3 but greater? 0? 0 is not greater. What about 4? All right, 4 is a little bit more. -4 times 4 minus 3. 4 minus 3 is 1. -4 times 1 squared is -4 times 1. -4 is a negative number. So since we picked the number right here, 4, because it was greater than 3, all the numbers on that side are negative. Now we're going to pick a number less than 3. You can pick 2. I'm going to pick 2. Why? Because it's close and I feel like it. It doesn't matter. You can pick 1, you can pick 0. They're all going to be the same answer. Once again, the number doesn't matter. All that matters is the sign. When you go into calculus and you're doing graphing and doing increasing, decreasing functions and concavity of functions, you'll be doing the same basic concept as a sine graph. You actually will be using sine graphs to solve these things. So, anyway, that's getting ahead till next year. -4 times -2 minus 3, -4 times -1 squared. -1 squared, negative times a negative is a positive. So -4 squared times 1 is -4, and that's also negative. So negative and a negative, and that's your answer. If you don't believe me, say we pick 0. -4 times 0 minus 3. -4 times -3 squared. -4 times 9 is -36. It's a negative number. Whatever you pick, whatever goes in here, because of this squared, this thing right here is always going to be positive. And because you have a negative in front, a negative times a positive, your answer is always going to be negative. All right? That's just the magic of how math works. All right? Hopefully, you guys aren't scratching your heads or your heads aren't about to blow up right now. Should be okay, because I will go over anything you need again. Problem number 2. What you're doing now is you're doing these problems on your own. All right. Letter A. Set these both pieces equal to 0. X plus 4 equals 0. X minus 2 equals 0. So, when x plus 4 equals 0, first step you're going to do is you're going to subtract 4 from both sides. X equals -4. X minus 2 equals 0. You're going to add 2 to both sides. X equals 2. -4 and 2 are my zeros. You don't have to write has zeros every single time. This is just so you guys can see. So you have a 0 at -4, and you have a 0 at 2. So now since you did this, what you have to do next is you have to pick numbers greater than 2, less than -4, and between -4 and 2. I always like to start with the smallest numbers. The book starts with the highest numbers. Whatever you do is fine with me. as long as you just do them in order. Don't go high, low, middle. Just go in ascending or descending. So I'm starting with -5 because it's right to the left of there. Plug it into my original equation. -1 times -7 is a +7, which is positive. Pick a number between -4 and 2. I always like to pick 0. All right? It's an easy number to do. 0 plus 4 is 4. 0 minus 2 is -2. 4 times -2 is -8. -8 is a negative number. And this thing boxed in. This is my actual sign diagram. All right, so let's pick a number bigger than 2. Pick 3. Still pretty small. And as long as it's to the right of it. Now, you don't really have to write the stuff in here I'm writing in. I'm just showing you why I'm picking these numbers. 7 times 1 is 7. Answer's positive, so there's your sine curve. Plus, minus, plus, and you have your -4 and your 2. The signs are just as important as these numbers down here, so don't mess that up. All right? So all you really need for your sine curve is this, though. You don't need these numbers in between. All right? B and C. Going over B. Set equal to 0. X plus 1 equals 0. What do you do to both sides? -1 from both sides. X equals -1. X minus 5 equals 0. Add 5 to both sides. X equals 5. You have zeros at -1 and 5. Notice -1 always comes first because negative numbers are less than positive numbers. Smallest numbers, because technically this right here is -infinity. This is infinity, so you make sure you're going ascending from the left to the right. Number less than -1 between these two. -2, right? Good. -2 times 1 is -1 times -7 is a +7, which is a positive number. Get that negative sign out of there. Number between these, 0. 0 plus 1 is 1 times -5 is -5. Negative number. Number bigger than 5 is 6. 6 plus 1 is 7. 6 minus 5 is 1. 7 times 1 is 7, which is a positive number. Plus, minus, plus. All right. X times x minus 3. You have to set anything that is a variable equal to 0. So you still have to set the x equal to 0. This is actually x equals 0. And that right there is your answer. And then x minus 3 equals 0. So, x equals 0, x equals 3, those are both my zeros. Okay? -1. -1, -1 minus 3, -1 times -4 is a +4, so you have a plus. A number between 0 and 3 is 1. 1 times 1 minus 3, 1 times -2 is -2. Negative number. 4. 4 times 4 minus 3, 4 times 1 is 4. Positive number. Once again, you don't have to pick these exact numbers as long as you pick numbers in between those pieces. All right. Any questions involving that problem right there? Are we all good? D, E, F. Hopefully you're good. All right. Problem D. Set it equal to 0. X equals 0. That's a 0. X plus 2 equals 0. Minus 2 from both sides. X equals -2. You have zeros at 0 and -2. Pick a number less than -2, -3. -3 times -1 is +3, so you have a positive. Number between these two is -1. -1 times -1 plus 2, -1 times 1 is -1, which is indeed a negative number. Can you pick fractions for these? Of course you can. But who wants to add and multiply fractions? Number bigger than 0, 1,000. Now let's just pick 1. All right, so 1 times 1 plus 2, 1 times 3 is 3, 3 is positive. Say you wanted to pick 10. 10 times 12 is 120, positive. There you go. You can pick whatever number you want. All we care about is the sign. I'm going to keep on drilling that into your brains. Set both of these equal to 0. Told you algebra heavy and everything. 2x plus 1 equals 0. you're going to subtract 1 from both sides. You get x equals 1/2. Missing something. X minus 4 equals 0. You're going to add 4 to both sides, and you get x equals 4. All right? The other animation can pop up there for something. It will. So you have zeros at, negative 1/2 and 4. All right? Whoa. Pick a number less than negative 1/2 is negative 1. Negative 1 is less than it. 2 times negative 1 is negative 2 plus 1 times negative 1 plus 4. So this becomes negative 2 plus 1 is negative 1 times negative 5. You get positive 5. 5 is positive. The number between these two is 0. 2 times 0 is 0. 0 plus 1 is 1 times negative 4 is negative 4. That is indeed a negative number. And a number greater than 4 is 5. 2 times 5 is 10 plus 1 is 11. Times 1 is indeed 11. 11 is positive, so you got plus, minus, plus. All right? So this is messed up, but everything else is okay. All right, problem F. Oh, there's my 2x plus minus 1. It would pop up eventually. Now watch how this one works. You got negative x plus 1, x minus 3 equals 0. This negative sign we don't need till later on. So you're just going to set these two things equal to 0. You set x plus 1 equal to 0. You subtract 1 from both sides, and you get x equals negative 1. X minus 3 equals 0. You're going to add 3 to both sides, and you get x equals 3. Now you may say, what do I do with this minus sign? Well, technically, if you multiply both sides by negative 1, this stays 0. This becomes positive, so you don't have to worry about it until you're plugging things in down here. You have your zeros at negative 1 and 3. All right? Pick a number less than negative 1, negative 2. Now you have your negative back. Negative 2 plus 1 is negative 1 times negative 5. So negative times negative 1 is a positive 1 times negative 5, which is negative 5. So your answer there is indeed negative. All right? 0. 0 plus 1 is 1 times negative 3 is negative 3 times a negative is a positive 3, positive number. Number greater than 3. Let's pick 4. 4 plus 1 is 5. 5 times 1 is 5 times a negative is a negative 5, which is negative. And there you go with your answer. I like the confidence you guys are having right now. I can feel it through my phone, which is recording all this. All right. Now what we're going to do is we're going to draw a sine diagram for G, H, and I. I thought this was going to be a quick lesson. This is a little bit long. All right. Set both of these equal to 0. 3x minus 2 equals 0, and x plus 1 equals 0. Remember I said don't worry about this negative to the end. So in order to solve for x, you're going to add 2 to both sides first. You get 3x equals 2. You're going to divide both sides by 3. Canceling that out, leaving you with x is 2/3. This one, x plus 1 equals 0. Subtract 1 from both sides, and you get x equals negative 1. You have zeros at positive 2/3 and negative 1. Notice the negative 1 comes first, even though I found this answer first. Because this is negative, and this answer is less than this answer. This is the biggest mistake made. All right, you just always want to put the thing that comes first. No, the smallest number is always the leftmost number. So, a number less than negative 1 is negative 2. Ready? 3 times negative 2 is negative 6, minus 2 is negative 8. Negative 8 times negative 1 is positive 8, times a negative is negative 8. Whoop, shoot. I messed that up somewhere? That should be negative 8, right? Right, my math, negative 8. I believe it's negative 8. All that matters is the answer is negative and it stays negative. Let's see, negative 3 times 2 is negative 6. Minus 2 is negative 8. Negative 1. positive 8, negative 8. So it should be negative 8. All right, I gotta fix that. 2g, negative 8. All right. Between these, you got 0. This is easy. 0 times negative 2 is negative 2 times 1. And a negative 2 times a negative is a positive 2, which is a positive number. Ooh, I'm supposed to knock out my contact. Number bigger than 2/3 is 1. All right, so 3 times 1 is 3. 3 minus 2 is 1. 1 times 2 is 2. And then you got a negative there, it should be negative 2. Negative 2 is indeed negative. Negative, positive, negative. Sometimes it stinks when you know what the pattern is and you mess up something simple like that. H. 2x minus 1, 3x, 3 minus x. Set them both equal to 0. Now, when solving for this, what you're going to do is you're going to add 1 to both sides. 2x equals 1. Divide both sides by 2, and x equals 1/2. 3 minus x equals 0. All I'm going to do here is add an x to both sides. And then you get 3 equals x, or x equals 3. 1/2 is less than 3, so you have zeros out, and 1/2 and 3. Number less than 1/2 is 0. 2 times 0 minus 1 is negative 1, times 3 is negative 3, which is a negative. Between these two, you got 1. So 2 times 1 is 2 minus 1 is 1. Times 2 is 2, which is a positive number. And a number larger than 3 is 4. 2 times 4 is 8 minus 1 is 7. 7 times negative 1 is negative 7, which is indeed a negative number. All right. Yes. I like when I don't make mistakes. Ready for the last one of this set of questions. You set 5 minus x equal to 0, and you set 1 minus 2x equal to 0. So when you're doing this, what you're going to do is 5 minus x equals 0. You're going to add your x to both sides and get 5 equals x, or x equals 5. 1 minus 2x, you're going to add 2x. Now you may say, why aren't you just subtracting 1? If you want to subtract 1 and divide by negative 2, be my guest. I don't really like negative numbers. So I do that. Divide by 2, and you'll notice you get the same answer. You get x equals 1/2. Now you have zeros at 1/2 and 5. Notice 1/2 is less than 5, so it comes first. Number less than 1/2 is 0, or any negative number. 5 minus 0 is 5. Times 1 is 5. 5 is a positive number. Number between 1/2 and 5 is 1. 5 minus 1 is 4. 4 times 1 minus 2. So 4 times negative 1 is negative 4, which is a negative number. Remember your PEMDAS, parentheses, exponents, multiplication, division, then addition, subtraction. That's why you're multiplying these before you do the 1 minus. 6. 5 minus 6 is negative 1 times 1 minus 12 is negative 11. Negative 11 and negative 1 is positive 11, which is a positive number. And you got your plus, minus, plus. All right? And that, my friends, is your answer. I think we get it pretty good. Only a couple little mistakes here. About 8. All right. So that gets done with that. You back for more? Go, do those problems. Let's go. Now we have squares. So because we're raising to an even power, you should notice something strange happen. X plus 2 squared equals 0. This is actually easier. You only have to set whatever's inside the equation equal to 0. Because x plus 2 squared, sorry. If I really want to know, this is really x plus 2 times x plus 2. So it's the same thing twice. So you don't need to really do it twice. All you really need to do is solve it once, because once one of these is 0, the other one's obviously 0. X plus 2 equals 0. You subtract 2 from both sides. And x equals negative 2. Whew. That's your only 0. Everything less than negative 2. 0 is not less than negative 2, but negative 3 is. Negative 3 minus 1 squared is negative 2 squared. Negative 2 squared is a positive 4. Positive 4. Number greater than 2. Well, you can do negative 1, or you can just do 0. Remember, pick 0 when you have the chance. 0 plus 1 is 1. 1 squared is positive 1. Positive. Positive, positive. Notice, even power, same sign. Because you're just going to be, the graph really looks like this. It comes down, touches the graph, goes back up. All right? These are parabolas. X minus 3 squared. Go. Done. X minus 3, set it equal to 0. Add 3 to both sides. X equals 3. 3 is your middle number. Pick a number less than 3. Number less than 3 is 0. 0 minus 3, negative 3. Negative 3 squared is 9. 9 is a positive number. Right? Pick a number greater than 3. 4. 4 minus 3 is 1. 1 squared is 1. And what is 1? 1 is a positive number. Right? All there is to it. I'm going to erase this stuff. All you care about is the inside, which is x minus 4. You're setting it equal to 0, okay? So we get rid of the negative, right? Because you really don't need it. Because technically, like I said, you're multiplying both sides by negative 1, and it goes away. You're square rooting both sides, and this is why it works. So you end up with x minus 4 equals 0. So you pretty much just set whatever is inside these parentheses to 0. Add 4 to both sides, x equals 4. You got your 4. Any number less than 4. 1, 2, 3, 0. All negatives. I pick 0, as usual. Negative 0 minus 4. So negative 0 minus 4 is negative 4. Now negative 4 squared, and negative times a negative is a positive 16. This negative stays negative on the outside though. Okay? This 16 is from negative 4 times negative 4. 2 negatives is a positive. So you keep that negative on the outside. So negative times a positive 16 is a negative 16, which is a minus. Pick a number bigger than 4. 5. 5 minus 4 is 1. 1 squared. 1. Negative times a positive 1 is a negative 1. And there, my friends, is a negative negative. There you go. I have to give myself time so I can pause quicker. This way I won't miss the button. Next 3 problems. You have a 2 out front. What does that do for our sign? Absolutely nothing. Like I said before, you're going to take whatever's on the inside and you're going to set that equal to 0. So you're going to take the 2. If you divide both sides by 2,
Excuse the interruption. Mr. Devereaux, could you please call the office?
Both sides, you get x plus 1 equals 0. All right? So all you care about is these parentheses and what's in it. You're just taking this stuff and you're setting that to 0. Because like I said, you divide by 2, you square root it, you end up with x plus 1 equals 0 anyway. All right? Subtract 1 from both sides. X equals negative 1. You have a 0 at negative 1. All right? Now, number less than negative 1 is not 0. 0 is on this side. Negative 2. Negative 2 plus 1 is negative 1. So 2 times negative 1 squared is 1. Okay? So this technically becomes negative 1 squared. Negative times a negative is a positive 1. 2 times 1 is 2, which is a positive number. Now you pick your 0. 0 plus 1. This becomes 1. 1 squared is 1. 2 times 1 is 2. Once again, positive number. All right. Next problem. E. Take this. All we care about is this again. So all that other stuff goes away. You're left with x plus 4 equals 0. Subtract 4 from both sides. X equals negative 4. You have a 0 at negative 4. So every number less than negative 4, not 0. Pick it like a negative 5. Negative 5 plus 4 is negative 4 squared. Any number squared is positive. So that becomes negative 3 times 16, which is negative 48. And negative 48 is definitely a negative number. Pick a number over here, like 0. 0 plus 1. This becomes 1 squared. 3 times 1 squared is 3 times 1. Negative 3 times 1 is negative 3 still. Because this is just going to be negative 3 times a positive number, so that's also negative. So this graph pretty much comes up to this negative 4, and then it goes back down. It's an upside down parabola. Problem F. Once again, you just care about the inside. So multiply both sides by negative 2. Square root both sides, and you end up with 2x plus 5 equals 0. You're going to subtract 5 from both sides. 2x equals negative 5. You're going to divide both sides by 2. X equals negative 5 over 2. You have a 0 at negative 5 halves. Negative 2.5. Number less than that would be negative 3. Look at this. I don't even remember what I put here, but this is what I would put. Negative 1/2 times 2 times negative 3. So 2 times negative 3 is a negative 6. Negative 6 plus 5 is a negative 1 squared. So you're going to end up with 2 times negative 1 squared, which is 2 times 1, which is 2. Negative 1/2 of 2. Wait a second here. 2 times negative 3 is negative 6, right? Let me make sure my math's right here. So this is negative 6 plus 5, right? So that means that inside now is negative 1. Negative 1 squared. Negative 1 squared is, that's what it is. So this whole thing then becomes negative 1 squared, which is 1. Negative 1/2 times 1 is negative 1/2, which is negative, and that's my answer. I had to do my math. Let me try this one. Let's pick 0. 0 is always easy. 0 plus 5 is 5. 5 squared is 25. Negative 1/2 times 25 is negative 25 over 2, which is negative. Whew. My arithmetic here wasn't too great. It'll get better. Ready for some more? What's that? D, E, F? All right. Whew. Last set of problems. This is scary though when one problem's the whole board. All right. So this right here is the last section. We did graphs. We did functions. Now what we're going to do is we're going to do a rational function. Meaning rational is a fancy word for fraction. So draw a sine diagram for the following. So what you're going to do here is when the function is 0, the numerator also happens to be 0. Okay? What does that mean? So that means that when this whole thing is 0, the top equals 0. So when x minus 1 equals 0, so when this equals 0, the whole f of x equals 0. So when x equals 1, your numerator is 0. That's part 1. Part 2, when the function is undefined, the denominator equals 0. So when this denominator equals 0, your function is undefined. Also meaning you can have a shift. So you set 2x plus 1 equal to 0. Subtract 1 from both sides. Divide both sides by 2, so you get x equals negative 1/2. So when x equals negative 1/2, your answer is undefined. When x equals 1, your answer is 0. Okay? 0, undefined. So let's look. X minus 1 over 2x plus 1 is 0 when x equals 1. And it's undefined when x equals negative 1/2. So you write these both in here as zeros. Okay? This is your 0. This is when it's undefined. So your sine curve can change. You just need to know that your 1 is a 0. So now I pick any number less than negative 1/2, which is not 0. That would be negative 1. So I'm going to pick negative 1, number less than here. Right? So you pick a number to the left, negative 1. Plug it into this equation. Negative 1 minus 1 is negative 2. Negative 2 plus 1 is is negative 1. So negative 2 over negative 1 is a positive 1. Well, positive 2. We don't know what 2 divided by 1 is. It's bad. Positive 2, which is a positive number. Boom. Pick a number between negative 1/2 and that. Yep. Our good old favorite, 0. 0 minus 1 is negative 1. 0 plus 1 is over 1. There's my negative 1, which is a negative value. So you're going to be above the curve here, then your graph's going to go below, and then at 1, let's pick a number bigger than 1, which is 2. 2 minus 1 is 1. 4 plus 1 is 5. 1/5 is positive. So our graph is going to be like above here. It's going to go below and back above. All right? Now, here's the deal, though. When you have your graph, all right, this is what this all means. This is all nice. I'm going to just draw this over here. I don't know what my graph looks like. This is what I do know, though. At 1, there's a closed circle. At 1/2, negative 1/2, there's an asymptote. Okay? This graph is somewhere in this spot over here, and then it goes through here, and it goes somewhere up there. So it's on the negative side here, it intersects my axis, and then it's on the positive side over there. That's all I know. Okay, so the graph over here can look like this, it can look like this. It's some type of concavity, but with calculus, you'd be able to figure that out. Isn't that neat? But you know where the asymptote is now, and now you know where the intersect is. So this is very, 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 very helpful when you're dealing with drawing graphs later on. This is just a piece that we're going to use later. All right, so number 4, draw a sine diagram for the following. All right, so you set the numerator equal to 0. X plus 2 equals 0. What you're going to do to the top and the bottom is you are going to subtract 2. X equals negative 2. Set the denominator equal to 0. You're going to add 1, and you get x equals 1. So this is where my asymptote is. This is where my x-intercept is. So negative 2, 1 has a 0 at negative 2, and it's undefined at 1. Pick a number less than negative 2, like negative 3. Negative 3 plus 2 is negative 1, divided by negative 4. Negative over negative is a positive 1/4, plus. Pick a number between. Our favorite number, 0. 0 is a number. 0 plus 2 is 2, divided by negative 1. Negative 2, what did I just say? Negative. Number larger than 1, 2. 2 plus 2 is 4. 2 minus 1 is 1. 4 divided by 1 is 4. 4 happens to be positive. All right, and that's all there is to it. Letter B, letter B, letter B, letter B. Numerator equals x, so you just set x equal to 0. That's easy enough. X plus 3 equals 0. Subtract 3 from both sides, x equals negative 3. So you have a 0 at 0 and a negative 3 at, it's undefined at negative 3. Negative 3 comes first because it is less than 0. Pick a number less than negative 3, like negative 4. Negative 4 divided by negative 4 plus 3 is negative 4 divided by negative 1, which is a positive 4. Positive. Pick a number between these two, negative 1 or negative 2, it doesn't matter. Negative 1 divided by this is negative 1 over 2, which is negative 1/2. Negative. Number greater than 0, such as 1. 1 over 4. 1/4 is a positive number. That's it. C. Numerator, x plus 1. Subtract 1 from both sides. X equals negative 1. That's my 0. X plus 5. Subtract 5 from both sides. X equals negative 5. So it's undefined at negative 5 and has a 0 at negative 1. Negative 5 is less than negative 1. So you put it left in the number line. Number less than negative 5 is negative 6. So negative 6 plus 1. Negative 5 divided by negative 1 happens to be 5. 5 is a positive number. 0 is not between these, but you know what it is? Negative 2. Negative 2 plus 1 is negative 1. Divided by 3, negative 1/3. Oh, that's the end of the school day. I'm still going to push through to the end of this. All right, so that's a negative. See, that's how much I like you guys. 0 plus 1, 1/5. That is positive. And this is your sign diagrams for rational numbers. Hope you're feeling good, because we got 3 more. Alright. Almost done, almost done. Set the numerator equal to 0. X minus 2 equals 0. Add 2 to both sides. X equals 2. Set the denominator equal to 0. Subtract 1 from both sides. 2x equals negative 1. Divide both sides by negative 2. By positive 2. X equals negative 1/2. 0 at 2, undefined and negative 1/2. Negative 1/2, 2. Number less than negative 1/2 is negative 1. Negative 1 minus 2 is negative 3. Multiplication before addition. Negative 2 plus 1 is negative 1. Negative 3 divided by negative 1 is a positive 3. Positive. Number between these two is 0. 0 minus 2 is negative 2. 0 plus 1 is 1. Negative 2 over 1. Whoa! Negative 2 over 1 is, I was doing good there too. Negative 2? Ah. Negative 2 is negative. I still got the answer. 3. 3 minus 2 is 1. 6 plus 1 is 7. 1/7, please? Yes. That is a positive number. Got it? All right. See, I'm human. I make mistakes. And I checked this and I still couldn't get that one. Numerator. Set it equal to 0. What you're going to do here is you're going to subtract 3 and divide by 2. So you get negative 3/2. This becomes 2x equals negative 3. Negative 3 divided by 2 is negative 3/2. 4 minus x is equals 0. That's when your answer will be undefined. Add x to both sides, you get 4 equals x, or x equals 4. So you have 0 at negative 3/2, undefined at 4. Negative 1/2, number less than that would be negative 2. Negative 4 plus 1 is negative 1 over 6, which is negative 1/6, which is negative. Pick a number between a negative and a positive. Good old 0. 2 times 0 is 0. 0 plus 3 is 3. Divided by 4 is 3/4. Positive. Number larger than 4. 10 plus 3 is 13. Divided by negative 1. Negative 13, which is negative. Right? F. Add 1, divide by 4. So 4x equals 1, x equals 1/4. 2 minus x equals 0. Add x to both sides, you get 2 equals x, or x equals 2. All right? You have a 0 at 1/4. You have undefined at 2. A number less than 1/4 is 0. 4 times 0 is 0 minus 1 is negative 1 over 2, which is negative 1/2, which is a negative number. A number between 1/4 and 2 happens to be 1, right? 4 times 1 is 4, minus 1 is 3. Divided by 1 is 3. 3 is a positive number. Right? Number greater than 2 is 3. 4 times 3, minus 1. 12 minus 1 is 11. Divided by negative 1 is negative 11, which is a negative number. All right? Pretty easy. Got it? We got 3 more to do. Ready for the last 3? HI. I think it's the last three. Hope so. Run out of batteries, run out of time here. All right, number 4. G. Set the numerator equals 0. 3x equals 0. X equals 0. X minus 2 equals 0. X equals 2. 0 at 0, undefined at 2. Number less than 0 is negative 1. 3 times negative 1 is negative 3. Divided by negative 3 is 1, which is positive. Okay. 1 is between 0 and 2. 3 times 1 is 3. Divided by negative 2. Divided by negative 1, which is negative 3, which is negative. Number greater than 2. 3. 3 times 3 is 9. 9 divided by 1 is 9. 9 happens to be a positive number. Okay. H. X minus 1 squared equals 0. So x minus 1 equals 0. X equals 1. Right? Remember, you don't care about the squared. And it is undefined when x equals 0. 0 at 1, undefined at 0. Pick a number such as negative 1. Negative 1 minus 1 is negative 2 squared, which is 4. 4 divided by negative 1 happens to be negative 4, which is a negative number. We're going to have to pick a fraction. We have to pick half. So let's pick half or 0.5. 0.5 minus 1 is negative 0.5, or negative 1/2. Negative 1/2 squared is actually positive 0.25, or positive 1/4, divided by a half. All right, so that'd be 1/4 times 2, which is 1/2. Boom, which is positive. You can use decimals, you can use fractions, doesn't matter. Number bigger than 1, 20. Now let's go with 2. 2. 2 minus 1 is 1. 1 squared is 1. 1 divided by 2 is, wait a second, that's a positive number. So we got negative, positive, positive. Is that allowed? Of course it's allowed. It looks a little weird, but you can do it. All right, so don't always get afraid when you get your answer. Whew. I. Look at this. You are glad you're done, right? Okay, here comes I. 4x equals 0. X equals, divide by 4, 0. X plus 1 squared equals 0. X plus 1 equals 0. Subtract 1 from both sides, and x equals negative 1. You have a 0, 0. You have undefined at negative, you have an undefined at, I should say, negative 1. All right? Number less than negative 1 is indeed negative 2. 4 times negative 2 is negative 8. Negative 2 plus 1 is a negative 1. Negative 1 squared is positive 1. So you get negative 8 over 1, which happens to be negative 8, which is a negative. I have to pick a fraction here again. Sorry, guys. Negative 1/2. All right. The only reason I use 0.5 instead of 1/2 is it fits better. It's better for the projector. So 4 times negative half of 4 is 2. So this is a negative 2 on top. All right. 1 minus a half is positive a half squared is 0.25, or 1/4. So you have negative 2 times 4 is negative 8, which is also a negative number. Number greater than 0 is 1. 4 times 1 is 4. 1 plus 1 is 2. 2 squared is 4. 4 divided by 4 is a positive 1. Positive. Look at this. Positive, negative, positive. Negative, positive, positive. Negative, negative, positive. Why did I say all that? Oh. All right. It's exhausting, isn't it? J, K, and L. I thought we were done. What am I at? I am at an hour and 10 minutes already. I thought this would take 40 minutes. All right, J. Set both numerators equal to 0. So you set x plus 2 equal to 0, x equals negative 2. You set x minus 1 equals to 0. X equals 1, so you have two zeros. To find when it's undefined, you set the bottom equal to 0, the denominator, 3 minus x equals 0. Add x to both sides, and x equals 3. So now I have 1, 2, 3 pieces here. I have zeros at negative 2 and 1. And I have undefined at 3. This little symbol right here, that's the at symbol. So negative 2, 1, 3. Pick a number less than negative 2. Negative 3. Negative 3 plus 2, negative 3 minus 1, 3 minus negative 3. Negative 1 times negative 4 is positive 4 over 3 plus 3 is 6. So 4 over 6, which is positive 2/3. There's our answer. You don't have to reduce this. All you care about is the sign. Right here, number between negative 2 and 1, 0. 0 plus 2 is 2. 0 minus 1 is negative 1. So 2 times negative 1 is negative 2 over 3 minus 1.5. So negative 2 divided by positive 1.5. Okay? It doesn't matter where the negative is. I just threw it on bottom. That becomes a negative number. That's all you care about. All right? Got it? Between these two, you got 2. 2 plus 2 is 4. 4 times 1 is 4 divided by 1. Positive 4. Number bigger than 3. You got 4 again. 4 plus 2 is 6. 6 times 3 is 18 divided by negative 1. Negative 18 or a negative number. Plus minus, plus minus. All right, let me move this out so it's not in the way, so you can see. All right. Problem letter K. One numerator, 3 minus x equals 0, x equals 3. So that's where your 0 is at. Two denominators. 2x plus 3 equals 0. You're going to subtract 3 from both sides and divide by 2. So you get 2x equals negative 3. X equals negative 3 halves. X minus 2 equals 0. You're going to add 2 to both sides and you get x equals 2. Okay? 0 at negative 3, undefined at negative 3 halves, and 2. So you got negative 3 halves, 2. A number less than negative 3 halves is negative 2. 3 minus negative 2 is 5. This becomes negative 4 plus 1, which is negative 1 times negative 4 is 4. So it should be 5 over 4, which is a positive. It feels good when you get the right answer. 0. 3 minus 0 is 3. 0 plus 3 is 3 times negative 2. So this should be 3 over negative 6. Come on. Yes, negative 1/2. All that matters is positive, negative. That is a negative. Number between 2 and 3. Fraction. 2.5. 5 halves. Whatever you want to call it. So 3 minus 2.5. All that matters here is you get a 0.5, a positive on top. 5 plus 3 is 8. So positive, positive. 2.5 minus 2 is 1/2. Another positive. So positive, positive, positive. I know my answer is going to be positive. I can actually do this. 1/2. 8 times half. So 1/2 over 4 is 1 over 8. But it's positive. That's all that matters. A number greater than 3 is 4. 3 minus 4 is a negative. Negative 1 up top. 8 plus 3 is 11. Positive. 4 minus 2 is positive 2. 2 times 11 is 22. So you got negative 1 over 22, which is a negative number. Once again, the numbers don't matter. All that really matters is the signs. I'm really happy I got the numbers. You should be too if you do. I think this is the last problem. I could be wrong. Been a long day. All right, so set the two numerators equal to 0. X plus 5 equals 0. X equals negative 5. X minus 1 equals 0. Add 1 and x equals 1. Those are my two zeros. Find out when this is undefined. X plus 2 squared. Is that equal to 0? So when x plus 2 equals 0, you subtract 2 from both sides when x equals negative 2. So I got zeros at negative 5 and 1, and an undefined at negative 2. So that means intercept, intercept, asymptote down the middle. The weird things happen usually at the asymptote. So number less than negative 5 is like negative 6. Negative 6 plus 5 is negative 1 times negative 7 is a positive 7 up top. Negative 6, well, this is always going to be positive on bottom because it's squared, so negative 4 squared is 16. So 7 over 16 is a positive. Number between these two, -3. Is that what I picked? Good. This gives me -2 times -4, which is -8 over -1 squared, -8 over 1, which is a negative. All right? Between -2 and 1, you can pick 0. No fractions. Yes. 5 times -1 is -5 over 16. Over 4. 2 squared is 4. That is another negative. Okay, we have an asymptote here. So we have both of these things under it. That's okay. And then finally, after 1 is like a 2. 7 times 1 is 7 over 16. That is our positive. All right? Whew! A lot of stuff there. All algebra. Oh! That's it. I'm going to leave it just like that. I hope I'm not in the dark. Hopefully you guys are experts at this now. I'm glad I could teach it to you. I talk longer, but I'm very exhausted after doing this after teaching all day. So, until the next lesson, hopefully you guys understand how to do all the science stuff now. I will see you guys again next lesson. All right? Take care. Have a good day.